Okay, so the idea is that all calculations are done without taking flipped into account. Only when when one board follows from another board, flipped becomes important. In the end, it only has to do with what we printed. That already works. If I print a board, so the flip bit is set. That means actually only that this function that writes to no stream will mirror the whole board before printing it. That's the canonical meaning of flipped. So if it is being used anywhere else, flip that is, then we have to look at it. Start with the header. So I'm going to change this comment. Even separating it from the rest, because yeah, it's just an afterthought thing. Only relevant to the printing. I think this is where I made the biggest mistake, allowing to construct something with the flipped. The problem here is that only works if I pass canonical coordinates for everything, although it does canonicalize it. So I can either pass canonical or mirrored coordinates here, and then it will be flipped back. It's just very confusing. It's error prone apparently. The default constructor, the default constructor creates exactly this position, where the blacking is on the main diagonal, so that is not flipped, it is already canonical. We can just use 0, 0 and then set the flip to false. If the blacking is on the main diagonal, so if n equals m, then it is in a non-flipped state. No, it's in a canonical state, which means that I think I made a mistake here as well. I mean, I just changed the meaning of flipped by changing this comment. So it doesn't really matter what flipped is here. In terms, for the king, because mirroring the whole board doesn't change the position of the black king. But the rook would be moved over here and the white king would be moved over here. So well, not moved, but shown as being there in an M-bar slot. Anyways, because I entered the coordinates of the white king as 2-0 instead of 0-2, and I mean this position, the flip is false. Okay, I have an excessor for flipped. That's it. So what about this thing? But feeling that it just doesn't make sense to allow constructing a board with flipped already set, actually. Or does it? Ugh. Doesn't, does it? It just doesn't. I don't know. I want this to work like this. Might as well erase it here. There's always a start false. Which means that, yeah, man. Yeah, I'm rethinking the flipped thing, the boolean. It caused all kinds of problems because it's just too hard to understand. So now I'm updating the comments and some code, I guess. I mean, by just only allowing to construct a board with the flip bit off, initially anyway, that means that the coordinates that we pass here are just the exact coordinates. The coordinates as they will appear after printing it. The fact that canonicalize is called is only because if you pass a blacking that is not canonical, then yeah, that we don't want to store that. So then we flip the coordinates of all pieces and mark the set flip to true, so that it's still being printed the way that these coordinates were passed. I think this is the correct way. I also have the feeling that the user should in no way be concerned with this flip thing. It just should be completely internal somehow, as much as possible anyway. So why do I have an accessor for it? Let's delete it as well, unless I need it for the printing. Yeah, I need it for the printing because this is a free function. Let's make this a friend, so that I can access flipped still. This is the only function that should be allowed to access flipped. And if the board is flipped or not is irrelevant, isn't it? More or less. I mean, I'm passing a board. You just print it. I mean, it's kind of trivial, I think, that the board might be flipped. So I just pass some boards. What happened? This was already called board. Or temp board. Yeah, so no more flipped accessor, and then this must be a friend. Now this is the only place where flip still exists in the header. And here it is used correctly. And I think that it only existed in the board.cxx apart from there. So now I have to start to look at all the places where flipped was used in board.cxx. Another print. What the hell? Oh, never mind. Yeah. The operator that prints to O string, operator less than, is just printing text. This is the function that prints the ASCII art stuff. So that needs access to the flipped as well, of course. And this should already work. And since this is a member function, it also has access to the private flipped. So yeah, that one should stay. That's what flipped is for, printing. And then of course canonicalize itself, that also has to do with flipped. So we get the M and N coordinate of the, maybe we should put X first. Well, it's of course X comma Y, because X is before the Y in the alphabet, and now I use N and M, where N is X. A, B, C, K, L, M, N. So now it's the other way around. Yeah, still, I don't know. Maybe I should swap N and M. But I've gotten used to N being X now, so it still probably makes more sense to swap the notion of N and M. Okay, so you get the coordinates of the black king, and if the flip bit is set, then I swap it. Why, actually? I don't think that makes much sense. I simply need to toggle flipped if equal mirrored. There's no reason to we need to mirror it if the current position is not canonical. So not is canonical, then flip it. Ugh. And that should not have an influence on how we print it. So in that case, flipped must be not flipped. So we still, despite the mirroring, we still print it in the same way. I think this is the only thing I need. Maybe it should change flipped into print flipped. To make it way more clear that it is only with respect to how it is printed. Yeah, I like that idea. I'm gonna rename flipped to print flipped. Okay, and it's used in distance less. Why? What does printing has to do with that? Nothing. Well, that is apparently I'm taking into account that I want to be able to compare a flipboard, and I also I'm taking to print flipped into account for sorting. It's a bit counterintuitive. Yeah, I mean it's not clear, but it how do you say that? If you have a complete overview of the whole program, how everything works and how it should be, and I don't, then you could say, oh, this is wrong, this has to be like that. But that's just one way to approach it. I rather approach my program from I don't know how the whole works together, and at the moment it doesn't even work, and I don't have an overview. But if everything would be working the way it should, then I think that this function should not use print flipped. Why? Well, because it has print in it, and this is not related to printing, period. That then means that distance less, which is part of the algorithm, should only work with canonical boards. Well, to begin with. And if all boards are canonical, then do I really care how I want to print it? No. Well, at the very least, of course, it must be a canonical board. Otherwise, things would go wrong. Let's add an assert for that. Oops, sorry, I should not play with this, it makes sounds. So I'm using this distance function to sort the positions stored in my map. I'm only going to store canonical positions in the map. And I think that everything I store just represents two positions, namely the position that I store and the flipped position. It's not really, this is not really using flipped, of course. Well, it's using it, but it's just passing it to another distance less. And I think in the end we just get to the position. Or square. It's called square these days. And then it's being used here. Yeah. Okay, it's not clear. It's totally not clear if I can do this, what I just said. Implication of removing flipped here. Let's say we just, well, that means that I use the canonical coordinates as they are, because now we know that they are canonical, at least. That gives a certain ordering. Under what circumstances do I want to compare two positions? See, if the flipped is true, I'm going to print an otherwise canonical board as in the flipped state, which means that the king, the black king, moves from its canonical position, meaning in the upper right triangle of the board, to the lower left triangle. And canonical means that it isn't in that part of the board. So if I want to compare a position, if I want to compare two positions where one or both are flipped, that means that those positions represent a position where the black king is non-canonical. And I want to compare that for some reason. I shouldn't want that. That's the whole idea of using flipped. That we literally only work with the positions where the king is in the upper right triangle. Let's just demand that flipped is not set. Does that make sense? It's kind of irrelevant though. Yeah, it depends incredibly much on where I use it. Afraid I'm going to have to investigate that first. This is just a definition. This is a declaration. It's another definition. And another definition. Or declaration, actually. This also. No, this is a declaration. This is a definition. This is definition. This is a definition. Here we really use the thing. This is a declaration. Here we have the definition. And this is the thing that I wanted to change, isn't it? No, that was square. Yeah, okay. This is board distance less definition. Are you telling me that this is the only place where it is being actually being used? Okay. Yeah, looks like that. Yeah, it's a compare operator for the standard map that we use. So it's hardly interesting. It's just I just have to guarantee some ordering. Doesn't even really matter that much, does it? Well, yeah. I think in the end it might mean it might be important to have shorter distances ordered first, but the flipping only doesn't really change the distance. It was just an afterthought ordering. So I think I can do anything I want as long as two equal positions compare equal. Okay, one is not less than the other. In other words, the flipped bit is just absolutely not interesting, is it? Is it? So that depends then, of course, what I'm adding to this. And it's called data here. I think that I should just not store flipped positions in the map. or completely ignore it, but I'm afraid that this is going to bite me, because in the end, yeah, I want to extend data with a list of positions that we can reach. There suddenly it does become important. It's not purely printing. So if I have stored some board and I want to know which positions we can reach from there, then sometimes we have to make a link to a board that is mirrored, because in between there is again a move where the black king crosses the diagonal, and then it does track something important. Damn it. So now suddenly flipping is no longer just printing. It actually means a position. Because you want to link two boards together as being, you can move from here to there. But on the other end, you can only think about it as you can move from this position to that position, where the position that you move to is actually a flipped position. I mean, why not? Just because they're equivalent, basically. So maybe I should just make a link to a flipped position and then figure out during printing what flipped should be. You start from some position and then you find the next position. It is possible. It's always possible to see that it was flipped in between, because you have three pieces. Only one moved. So if three are mirrored, and well, that's not true. Is that true? Well, you can only it can only be flipped if the black king moved, so the white pieces don't move. So we have a problem if both white pieces are on the main diagonal. Then you can't see if they were flipped or not. I think it must be possible. Of course it must be possible. So it must be a legal move. Is it possible that flipping is equal to a legal move? Yes. Afpurna. Let me draw a chessboard to show what I mean. Tools, board editor, clear boards. So flipping means we mirror in this diagonal here, yes? And we have a king and a white king and a white rook. So this position, if you mirror that, then nothing changes, because all the pieces are on the main diagonal. And I think I'm going to make an effort of if the black king is on the main diagonal, then flipped will be false always. So this is false, 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 and this is true. Yeah, so if the black king is in this triangle and I want to display that, then I will have to flip it, because the canonical sorry, canonical positions are the positions where the king is in this triangle. So the main diagonal and everything up here. So if I want to print or show a non-canonical position, so where the king is in this part, for example, I want to show this position, then we can only store canonical positions. So I would put the king here, and then this is what is stored, and we print it flipped. So everything is flipped in this diagonal, and then this is being printed. So that's how we see it. And now the question was, is it possible that I have two positions I was thinking about this position and then moving the king over there. So I think the question was, is it possible that you have two positions where there is one move being done between the two, with as a result that it is not possible to figure out if the position needs to be flipped or not. And I think that is indeed true. Yeah. Namely, if the king is here and you move it over there, then that becomes indistinguishable from moving the king over there. Because both are stored like this. So if we do not have access to the flip bit, then you just see this position, and we don't know if we mean this position instead of that one. The demand for that special case, however, is that these two are on the main diagonal, because if one of them is not on the main diagonal, for example like this, then if this is the canonical position and we move over there, then this is the resulting position. While if you move over there, then it is made canonical by doing this. So then you have this position and this position. And then of course you see that it is flipped because the white piece moved. So then now is the question, if all white pieces are on the main diagonal, is it a problem that we don't know which position I mean? I mean, these two are exactly equivalent, this one and this one. It's just a mirrored move order. So it should not be important. It should not be important. We're just going to ignore this move. This will never be done then. Or rather, I can deduce that if you see the king move from here to there, then I know, of course, that it corresponds to this position, which is a move. The same thing holds actually for moving there. These two. So the king can move here and the king can move there, and both moves are each other's mirrored position. And it's the same for this move, and actually the same then for this move. But I think it is only the case for moving from the main diagonal. So if the black king is not on the main diagonal, is it now possible to do a move and then not know what move you did? So this is sorry. If you have the canonical, must be a canonical starting position, right? So this is canonical on the main diagonal. If it is not on the main diagonal, and we move from here to there, then yeah, then clearly we just moved from here to there, because even the flip position is the same. So we have to move from a canonical position to a non-canonical position. If you move from here to there, then we didn't move from here to there, because that's illegal. That's the mirror position. So in this case, I know it wasn't flipped. Only confusion can happen if we move from here to there, crossing in between the main diagonal. But also then we know, because this position cannot have been this position, because then you didn't move at all. So what you have then is a link from a position, this position namely, to itself. Yeah, okay, so if we have a link from a position like this to itself, then we have to conclude, oh, that means that we cross the main diagonal. But it is possible, right, to figure that out. And in this case, we'll have a link from here to there, and then we have to realize that this might be flipped or not flipped. And that is from the main diagonal, and that's to any position. Okay, so we can figure it out, I think. If we are not on the main diagonal, then it's simply the move as stored. If we are on the main diagonal, then any move must include the flipped one. So we have, it's one link represents two links. That's it. Except when you see that it is not the case. So if white is on the main diagonal, then and only if all of them are on the main diagonal, then any king move that goes off the main diagonal but is still canonical, that's we only store canonical positions, so it can go to one of these squares, then represents also the move there. So it represents then two moves. One link represents two moves. And only then. Otherwise you can figure out exactly which move it was. I think I'm going to go with that, meaning that we're going to not store flipped at all. I'm just going to reset flipped, because I don't know what it is. It should not matter. And if we never store anything that has the flip bit set, or I don't want to have to explicitly reset the flip bit. I'm just going to ignore it. So anything stored in the map will completely ignore the flipped bit, and the flipped bit that has no meaning anymore if it is stored in this map. That then means that we should not look at the flip bit in the distance compare, which means that this distance less here should not use the flip bit. This is the one on board, which means that I don't care about flipped, and we are not pausing it. the hell? I guess that's enough for now. I'm going to have to write code that does this decoding at some point, and then maybe I can move all this to there rather than have it here, but well. Okay, why is this using flipped? I don't think I'm using iterator anymore. Maybe I should just remove it. Yeah, it was running over all positions in some way, and then I abandoned that idea. I think all the iterators are no longer used. Let's delete it. Commented out code. Scary stuff without having it in Git. I really hope I will not regret removing all of this code. Uh-oh. No, just kidding. That is... not feeling 100% sure. Why all these errors? No matching constructor initialization of board. Yeah, because I'm using passing flipped. It's no longer allowed. Yeah. Okay, I think that preceding positions is like the place where all the bugs happened. And that's still using flipped. I think I can go back to that point, and so the grep sources for print flipped, where is it still used? Okay. So we're still in board. We were working here in board. Okay, print flipped. If print flipped, yeah, we already did that one, so that is necessary for printing. And canonicalize was rewritten, and this is the last one I did, which resulted in removing a lot of code. Mirror, yeah, guess so. And then preceding positions. And then printing it. Okay, so this function is the last one. And I believe that also this function is the only one that still uses... it's not. Who was that? Use the accessor. Nobody's using the accessor. I just got an error there. Pretty sure I got the error there. See flipped. Oh no, it's just reading it directly. Okay, so this is indeed in preceding positions. Yeah, no, that's the hardest part. Oh, what I should do? Let's get a glass so we can actually drink something. I'll be right back. Yeah. Where did my chat window go to? Nowhere. Hello, Crazy. My chat popped out and it just disappeared. What the fuck? No, I can't find how to pop it out. Nah, such lameness. Oh, what? Very normal. Hey, crazy, you're still there. Trying to pop out the chat again, but it disappears below this window. No, what? What's happening? Oh my god. Nobody understands this. Can't give you guys too much room. Need to see my code. No. No. I did physics for all the wrong reasons, like you don't even want to know why I did physics, really. Basically, when I was young, like much younger, and not as senile and stupid and forgetful as I am now, I was so brilliant that I thought I would do physics in order to actually mean something for humanity. I think my idea was to work on fusion energy. But all kinds of things went wrong, not related to me. Basically was just abused by the system. I studied at the wrong university, and then I was I should have gone to. I mean, if you look up physics, there's totally two different types of physics. Even two different universities concentrate on one or the other. Nobody told me that. I was autistic, and at that age, I wasn't able to figure that out myself. So I went to the university in the city of my parents, so I could continue to live with my parents a few years longer. Turned out to be the wrong university. So then I did not theoretical physics, but practical physics, basically, which is, of course, not suitable for wanting to become proficient in quantum mechanics and stuff like that. But yeah, and then I went to the wrong PhD thing. I already told that on the stream once, so I won't do it again, but it really sucked. Long story short, I didn't even finish my PhD, so I'm not an official doctor. And I hated physics so much at the end that I never worked as a physicist. I went straight into coding. If I had to redo my life, I would definitely study computer science or something like that. Or mathematics, maybe. But yeah, no way I would go into physics again. Yeah, exactly. I should have studied theoretical physics from the start. And then, of course, my mental instability. I suffered my whole teenage life and beyond from panic attacks and anxiety before the psychiatrist knew what it was. So that's not an easy life, you know. If I had gotten the medicine that I take now, I would have had a freestanding house on a hill somewhere. Pretty sure about that. But no. My life sucks. Well, I can still code. I'm good now. I mean, after a few decades of battling, I finally got the correct medicine. I mean, they caught up. At some point, I actually knew what anxiety was, and then I got the right psychologist and the right medicine. But yeah, by that time it was way too late to work on my career. My anxiety started when I was 12 and lasted my whole life basically until I really settled on those medicine. I had a dropout of a whole year because of an anxiety attack during my PhD, which also didn't help. Despite that, I have always high grades and I became number 8 of this country and in the mathematics Olympiad at 15, which coincided with suicidal thoughts and wanting to die and stuff like that. But still, I could still do those mathematical questions. I gave a much too long answer. But you ask a specific questions. It is not one. Is physics nice? No, physics good for a good major for people who enjoy coding and computers. Well, I told this before in the stream, but so I was diagnosed with Asperger's at some point. I think at some point, like way too late. Also, when I was 35 or so. Really, you cannot imagine how bad the mental health is still, I bet, but was decades ago. I was a teenager starting from 12 with continuous anxiety attacks. They just didn't know what it was. I got the most crazy kind of help. I won't go into it. This is a coding channel, but it's completely sad that... And I'm pretty sure that if they manage to call themselves a mental health specialist and knew absolutely nothing, that is still the case. I bet in 50 years they will know stuff that makes the current specialist be charlatans. What is the right word there? They have no clue what they're doing. Why am I looking at this movies thing? We ended up there. Oops. No, I'm not. I'm not downloading movies. Honestly. I think the main reason that I thought I could mean something for humanity was because when I was 18, I think, I did derive the relationship between gravity and time by myself. Just using high school mathematics and some things I picked up. And I did that faster than Einstein did. I think in half a year or so. But dysfunction. Probably would not have had any problems with it a few decades ago, 2 decades ago. Yeah, I did a lot of impressive things. But it never came to fruit, I'm afraid. I think mostly because both three things, I guess, mostly autism, of course, and so it was pretty bad socially. Didn't understand that stuff, and then the anxiety attacks, which kind of belongs. They go together, but they also had to do with just the way my brain developed. I completely neglected normal development. So say, I didn't understand what emotions were for until I was 18 and figured out what other people use emotions for by pure analysis and intelligence. So I kind of made a model of how the brain worked, and then at some point got an insight that people used emotions as their optimization output or input, both. It's a loop for the decisions they make. So say you are in a certain situation and you have to decide what you want to do. Then your brain simulates the world internally to predict what the result of your decision is. So say they can choose between A and B. And think, if I do A, then this will happen. If I do B, then that will happen. And then they choose the one that their brain predicts will give them the best feeling. So the emotion, they optimize their own happiness, basically. So there is no reasoning involved, if you get what I mean. And that was a really important insight in me, because an incredible amount of situations that I didn't understand before that point. Like, why do people do that? Why did they react that way? I finally understood. They didn't use any logic. They just optimized the situation on the wrong parameters, namely a totally irrational feeling. And then, I think that starting at 18, which is already pretty old, I think, I started to analyze social interactions and try to become, better at that. But in the end, I just had way too little experience because I was still very much on my own. And to become good with social interactions, you just need a lot of experience. I think that most people with autism that become very awkward in terms of social interactions is more the lack of experience than really that their brain can't do it. Of course, there's severe cases that, of course, they just can't. But in the case of someone with Asperger's, if you only sit behind your PC and only code and never go outside and have friends and play with them, then you don't learn anything. And then social interactions just keep being scared. Scary, I mean. Oh, wait a minute. I felt emotions. I had I had anxiety starting at 12. I feel a lot of emotions, strong emotions too. I just didn't understand what they were for. I didn't use them to make decisions. I mean, if you're overwhelmed with rational reasons to do something or not, then the emotions are not important. Logic is way more important. But okay, at some point I did figure out that they had a place in making certain decisions. It was just too hard for me. It's too not logical enough. For example, I remember this because I told the same story a few times during my life. At some point, I had to decide. So I had an electronics hobby as well, and I was working on something, and I blew up a transistor or something like that, or I just realized I needed it. So now the question was, will I get on my bike and bike? Well, I think it was half an hour bike or something like that, or at least say 20, let's say 20 minutes. Will I bike 20 minutes to the center of the city, to the electronics store, and buy that transistor? While it was almost closing time. So if I would not think about the problem at all and just jump up, run downstairs, jump on my bike as fast as I could, then maybe I could have made it. Yes, but it depends. It depends on traffic lights maybe. And I just didn't know exactly how long it would take me to bike. So there was a chance that I would do all this effort and get there totally tired, and then they just closed the door, or the door was already closed for 3 minutes, something like that. That possibility was there. So now I had to make the decision whether or not to do this, which did involve emotions, because on one hand I wanted to continue with my project and I needed a transistor, but on the other hand there was, let's say, 80% chance that I would be able to get the transistor, but a 20% chance that I would not get the transistor. But on top of that bad situation, that not being able to continue the whole evening and till the next day even, or maybe it was even weekend, I don't know. I think at that point I started to realize it was Sunday and the shop was closed anyway, so it didn't go. That's why I remember this. But that was a very, very difficult decision. So I was really breaking my head on this to weigh the importance of the happiness I would feel if I would make it and would be able to continue that evening with that project, against the negative emotions I would feel when the shop would be closed before I got there, because then it would even be worse off. I think that right now I would have jumped on my bike and did bike there as fast as I could anyway, thinking that even if the shop is closed, that's a positive thing, because then I worked on my condition. But that was not a thought I had back then. So because it was so difficult, it took a long time to think about it. Maybe I was thinking about it for 5 minutes and then started to feel frustrated that the longer I was thinking about it, the parameters changed. It was already unclear how certain it was I would make it, but that chance was quickly reducing. So I felt an immense amount of pressure as well, and I just couldn't make the decision. And if you compare that to other people, I think they just don't put thoughts into something like that. They probably look at the watch and say, I'm not going. Or they just go and then come for the closed door and only then start to think about, maybe I should not have gone because it was almost closing time. Well, I would really think really hard about the problems like that for 5 minutes long, trying to find the best solution. Hell, I would even think hard while crossing the street. I once wrote it on Reddit, I think. Someone claiming to have an IQ of 150, and I think that you need an IQ of 150 to do this. So I thought, well, if he can answer this question, then he's probably right. So I asked him, say, okay, do an IQ test. Now I can't remember anymore exactly how I phrased the question, but probably something like, if I cross the street, I do not cross the street in a straight line. Why not? And the answer is that what you want to optimize there is, it's like how light goes through glass with changing refraction index, where the refraction index is, in this case, the danger that you are in. So directly off the sidewalk, there are no cars yet, maybe bikes, but the cars are driving not exactly in the middle, but they drive left and right of the road, but not close to the sidewalk. So you can start more or less perpendicular to the sidewalk. Sorry, you can start diagonally, a small angle relative to the sidewalk, and then you have to start walking more and more perpendicular because you want to cross a dangerous part quicker. So I make a sort of an S move like that, and then at the same time looking, of course. If I look and there is absolutely no traffic, nowhere to be seen, then I just walk in a straight line. But if there's always a chance that there is a car that you don't see, so that's why you get hit, right? So yeah, that's the most dangerous spots on the street. I would be more particular. That's how my brain worked. I'm gonna try to answer Ricardo's last question. Well, did you ever feel angry? Not about this. Sad, maybe? Well, I found it unfair that I was like that. But it was mostly related to the anxiety, not because of autism. Autism always felt to me more like just being much smarter than most people and then thinking that the other people were stupid. And that's why they did the things different than I did. But you can get unhappy because of that, because interactions with other people were just very difficult or boring. I never went out, for example. I didn't understand why people would go out. Do you feel that autism is a plus or not in your life? I think it is actually a plus, because I think it's you can't have a lot of intelligence without also being giving in other fields. And I can't say I would have liked to have a life that is more ordinary, if that means that I had to give a lot of my understanding of the logical side of things. But I would have do everything to get rid of the anxiety. If I had to redo my life, then say some god came to me and said, well, you have to give this or that characteristic of your personality or capabilities or whatever, and then you won't have anxiety. Then I would say, yes, yes, let me not have anxiety, whatever it costs. Okay, I hope my answer wasn't so long that people left in the meantime. Let's concentrate on this. Preceding positions. Okay, so this finds positions that are possible positions from which the current position, and the current being the current object, can be reached within one ply. The current position someone is to move, for example, white is to move, then in the preceding position, black is to move, right? I mean, so to play is for then the preceding position. So the one that is to play is the one that is to play in the preceding position. And I just extract the coordinates of all the three pieces from the current position, as well as if that is flipped or not, for some reason. Maybe I shouldn't, the last thing. And then if black is to play, that means that black is going to move the king, and then we reach the current position after the black king was moved. And I do that by running over all positions that we can reach by moving the king to a legal position, because it must have been a legal position that we came from. So the king moves is kind of working both ways. It doesn't matter if you want to find a position where the king came from or where the king can go to. Just as long as you don't look at the current position being legal or not. Now the current position is legal, that's given anyway. So if he came from a legal position, then actually no, any position is just legal or not. It doesn't matter really. It's not related to moves, right? It's not that legal or not is determined by the move. It's determined by the position and solely the position. And a move is always from a legal position to a legal position. Period. So the current board is legal, so we find all legal positions that we could have moved from, which is exactly the same positions as we can move to. Therefore, king moves can be used for both. So king moves generates a vector, and that we can run over, and the vector is filled with squares that the king can be, the black king can be, have been in or moved to from the current position. But for that, it doesn't need to know whose move it is, because if the black king is in check, then it's an illegal position if white is to move, because then white can take the king. So he passes the whole board to king moves, so that it can take into account whose move it is. And this is the color of the king. We're going to move the black king. But it returns squares and not positions, which is maybe not a good decision, because then I need to construct boards from that square, and that's where it goes wrong all the time. And then we repeat the same thing, but then from that position. So let's say adjacent board is now a position where black is to play and can reach the current board. But here we loop over all moves that the black king can make from that preceding position. And one of them is going to be the current position, but there are also other positions. If there is even one other position that is better, then we should assume that the black king will move there and not to the current position, and then we should ignore this this square because it just won't go there. Currently I'm only printing it. But okay, but this printing is sometimes nonsense, so we have to fix this code. Or this. Anyway, so that means that then it uses the just generated adjacent position as the current board. And then again moves black. Is that correct? That would only be correct, I think, if in the adjacent board white is still to play. Just like white is to play here. But king moves itself checks that anyway. It just checks that if you pass, if you want to move the black king, then the board that is passed must have white to play. So apparently that is the case. Of course it is the case, because I'm telling it that white is to play. Okay, so far so good. So yeah, the only thing that really goes wrong here is the construction of the board itself. I'm constructing the board now by passing flipped, but this is no longer possible. I remove that. So now it should compile, because I simply removed it. No longer passing it to the constructor. But I don't think we'll get correct boards still. Something has to be done here. The worst thing that can happen is that the whole position, flipped or not flipped, is just wrong. So even flipping it afterwards doesn't help. And that happens if the square that is returned, it does not match the coordinates of the white king and the white rook. However, I think that's not possible, because king moves simply find the square, even non-canonical squares. At least it should. I think I already changed it. So we run over all the deltas. One step left, one step right. One step down, up, I mean, one step down. Gives us 8 possibilities, because we are skipping then the 0-0 case. We don't go off the board, blah blah blah. And then we do that step, at least we calculate the square where the king then goes to or came from. That's why I call it adjacent, because yeah, it's just an adjacent square now. By adding that delta to the current position. Then we change adjacent board by simply setting the new coordinates of the king, depending on whether the black king or the white king was requested to be moved. Where adjacent board is a copy of the original position. So all pieces stay exactly where they are, and the king is moved to the adjacent square. That might lead to a non-canonical situation where we move the black king and the black king is crossing the main diagonal. That is, for example, if this is the position, we generate all possible moves, then we do that one and that one and that one and that one and this one. And this one now, we cross this diagonal. We come in this triangle here. All the other steps, all the other moves would be canonical. They are still part of the other triangle, the upper triangle. In that example anyway. But you don't care, right? So the corresponding square is still correct relative to the squares of the white pieces. And I'm now checking if that position is legal or not. So is legal must work for non-canonical positions. And I think it is. It's yeah, so just completely unrelated to where the black king is or not. So we can test that if it is illegal or not. Anyways, for example, if the white king is here, let's say this is the position, and we generate this move, then this is illegal because the kings are not allowed to be next to each other. While, say, if I would canonicalize the position of the king, with only having squares there, so I flip the whole, well, I flip the coordinates of just the black king, then it would be legal if we don't also flip this. So in the end, of course, we're going to flip it like that, and which again gives an illegal position. But it's being tested in this situation, and already rejected there then. Okay, I'm actually showing the position, which is, well, which should work, although it's not clear if it will be correctly flipped or not. But okay, I'm just printing it in a human visible way with the UTF-8 chess pieces. So you can quickly see what the position is and also know how it is stored in this object anyways. But I'm not returning that. We are returning just the square of the king. But okay, the rest didn't change. So now the correct board is this board, right? I mean, although it might be non-canonical. And that board can be reconstructed simply by using this square for the black king. And leaving the white king and the white rook at where they are. So yeah, that's now push back, and then I do construct it like that. The white is to move, and I'm just using the old positions for the white king and the white rook, and the new square for the black king. This is now again the same adjacent board. And the same holds for this. This is constructing a board by calling and place back, which is the same thing. I'm just using the old king position, the black king position, and the old white rook position, and the new square, which does belongs to the same things. Except for one thing. Here, well, in both cases. Let's look here. Here, the resulting adjacent board has print flipped false, because it's always constructed with false. While the original board might have flipped set. So inside king moves, the original board could have print flipped set here, which is copied here. And after constructing the board here, it's definitely false. So we lose that flipped bit. And now I would say if I allow myself to construct it with the flip bit, then it would be correct, but that's not true. That is only true for the white pieces. This is so confusing. Let's say the black king now is non-canonical, then this constructor makes it canonical. So we just copy the exact same coordinates in here, and then with print flipped false, and then call canonicalized. So it's not true that print flipped is always false. Print flipped will be set if the king did cross the main diagonal. So what we will see is I think I just have to mirror the whole board if the original was flipped. Is that correct? It looks like it. I think that's the trick. Yeah. No, can I reproduce that here? I have a board which is constructed from blah blah. I think that works. It should work. And then we do have to do the same thing here. Exactly, we don't. Now it depends on the flipped point of view. Of the adjacent board. So I do need my accessor back, or I don't, because I can just access it, right? Even in an object of the same type. What about this one? I think this one, even this one, right? Well, in these two cases, we know that the coordinate of CBK, that's the canonical. Now, the C means canonical. It means current, canonical, and constant. Amazing. But these are canonical coordinates for the blacking, per definition, because they came or copied from a board. Therefore, let me add a quick comment. So the coordinates of the blacking are canonical if stored in a board, but not necessarily what is returned here. That could be a non-canonical. So the CBK is definitely well, in the canonical triangle, the upper triangle, but Yeah, that means that, which means that the call to canonicalize of the constructor is not going to do anything, and the initialized print flipped as false. So print flipped will be false after this constructor. Although it can still be set by the call to mirror. And this is mostly just the same thing, right? You just move the white king or the white rook, it doesn't really matter. You never flip, so the only thing that is different with this one is that here we know that the print flipped is false after construction of the object. And that the thing is already canonical, the coordinates. But if the original wanted to be mirrored, then this one has to. I don't know. It's still. It's still not clear. No matching function for call to construct add. Yeah, well, I'm passing through here. We can no longer do that. What function is that? Oh, that's in main. Yeah, there's no reason to do it manually. I just tell it what I want. It generated like this, and we generate it with flipped coordinates. Now I'm curious if this worked. Well, it doesn't crash, that's one thing. Mate position. Yep, the blacking is mated. Made in one position. That's correct. The white rook can move here and then it's made. Now it's going to think. And it thinks the following board is not illegal. Well, that's true. And it adds that to index 0. And then it says adjacent board created from index 0. And it is exactly that position, so yay. Adjacent to what? Guess to this one. And this is white to play. That's not correct then. Here's black to play. That is correct. Black goes to the corner and then we give mate. That's the position I want to print. Let me see where this is printed. Probably in again. I need music. Let me fix the music. Yeah, whatever. So the wrong person is to move here. Well, explicitly saying that white is to move. Is that not true? No, it must be to play. We're generating boards here that are adjacent with to play, which is already the opposite of the current board. So whatever is being generated here is black to play. It's just the same as this black. And then the next move is adjacent to the adjacent board. So I'd say then white must be playing here. Yeah, and here it is correct. Just twice white here. This white. And that white, right? So it's the positions that are constructed are the adjacent positions with white to move. And that is to play, because to play is not black in that code block. Damn it, en nou ik hoorde hem. So we're trying to move the black king. We try to find a position in this board here where black is to move and moves the black king, right? So to play it must be black because we are going to move the black king. And this fails. So to play is wrong here. Well, to play is the same. No, it's not the same. It's the opposite as board here. So board is wrong then. Board has to play black. Yeah, that's not correct then. If you want to move the black king, you can't do that. Oh right. Yeah. I'm moving the black king again, but in this case we go forward. So this goes backwards, and now we go forward from the adjacent position. In that case, this color must be equal to that color, of course, because now we're going forward. It just black must be the one that is to play because we are going to move black king. Here's the opposite. And the position reached after moving the king must be white because we just moved the black king. So the assertus is wrong. In this case we are going forward, so yeah, it must be black. What kind of impact does that have then? So a moving color. Do I use to play for anything else than the assert? I don't. Note that on this board it is the turn of the color opposite to the color of the king we are moving. After the king moved, it is the turn of the other player. Note that on this board, this being the this pointer, so the current board, it is the turn of the color opposite to the color of the king. We are moving if we are generating preceding positions. After that king moved, it is the turn of the other player. Well, if we are generating next positions, Okay, so now this is still black to play. Black goes to the corner and then we give mate. And here's also black to play. Yay. Interesting fact that the illegal test is done on a non-canonical position. The black king is in the lower triangle because it's not flipped. Here it says flipped, here it doesn't say that. And then when we create a board for storage, it is canonical because now this was flipped. So internally the king is here, which is the canonical position. And what happens now? Potential alternate positions. Yeah, okay. So to be a new line in front of this as well, I think. Potential alternate positions means just this one. There's a test for it, so it is the same position. But this is not illegal, therefore it is returned. And this is the position that is the potential alternate position. And the thing that is generated from, I'm not sure actually. I would say the king was here and now it moves up. Why doesn't it take the rook? Yeah. I can't even store that the rook is taken. Ouch. Yeah, no. I think I rejected that. So it generates, the king goes everywhere, and here the kings are next to each other. If the king goes from here to there, it's in check and next to the king. If it goes here, it's in check. And if it goes here, then the position itself is illegal because the king and the rook occupy the same square. Thus missing that we could also have taken the rook. Black is not forced to go into the corner. No, you're not allowed to go where my rook is. The rook is already there. Damn it. But okay, that happens. And, I'm just testing the flipped stuff at the moment. So now it concludes that this is made in two-ply position because the king must go to the corner and then we give mate. Now we go to the next position, mate in one position. Yep, you can give mate there. And then it's almost the same thing, right? Just the rook is one square further this way. And this time it is correct that the king is forced to go to into the corner. So we get mate in two-ply position. Black goes up and then we go there, yep. And then for the rook here, that's exactly the same thing, right? And then the rook goes one down. Now we should at the very least see that the king also can escape, because it doesn't take the rook then. So this is mate. This is then made in 1. The rook just goes here. And that means that this is an adjacent board, so the king could have been here and then moved to into the corner. So adjacent to the end position, right? If it from here we could go into the corner, but there are other possibilities. One, it does go to the corner, but we can also go down, and then it's not made in 1. So that is now generated. And then I have no other clue why this is appearing again. And now the king takes my king. Fuck. No, it's not working. It's still not working. Arg. Yeah, the kings are both on the same... What? Where does that even come from? I think from this. Just canonicalized it by moving this king on top of that one. Yeah, this is the alternate positions that we could move to from the adjacent board to the mate in 1 position. So the adjacent board is the king here. Correct. And then the alternate positions has the king there or there. No, let's check. It can only go there. So it's going to say that it is not illegal. No, indeed, that would be this one. Add it to index 1. White to play. No, white is not to play. Or is it, actually? Yes, it is. So black was here and black just moved the king here. Now it's white to play. And then we continue with printing the conclusion of the potential alternate positions. And it prints this one like that and this one like that, where the king just moves on top of that one. Okay. Didn't change anything, just add the debug output. This was the problematic thing, and yes, it says it was created from index 1. And this is added to index 1. So this is the position it should have been. So we have just problem with the king being flipped. Now we don't call mirror at all. There we still get this position created from index 1. So same thing. So mirror wasn't called anyway. Why is this not working? Oh, I see. Because I'm using CWK from the previous position instead of from the adjacent board position. So in this loop I use CWK and CWR. But we should be using adjacent board. So I think I really just shoot the return boards from king moves, because it's a lot of code duplication to begin with. But well, maybe after I get it working. Well, that sucks. No, it is flipped. What is not flipped, rather? It should have been flipped, but it isn't. Probably testing the wrong flips as well. Testing the print flips from adjacent board though. Hè? That's bullshit. I must flip board. And it's flipping the wrong board. And still not good. It is flipped though. Okay, again. So we have adjacent board with black to play. Black can go to the corner, yes, but black can also go to 0-2. So it's not legal to go to the corner. White to play. This thing is saying that it is flipped with the king in the corner. Ouch. Can you simulate the universe? No. The following board is not illegal. Indeed. White to play. It's not true. Black to play. No, it's not. Sorry. This is correct. I'm not happy that the flip is set here, I must say. Though it shouldn't really matter. Or should it matter? Oh, of course it matters. Oh, right. Yeah, that's basically... Oh, what? Confusing, is it? It is... Yeah. Anyway, what is printed is correct, so it should be flipped, or I have to change the coordinates of these things. And then unset flipped, which is probably what it should be doing. AKA, that is something that Sentai should be doing then. Board is not illegal. But okay, no, it's correct. It's just an illegal check. So this board can be non-canonical. So the king came from here, and this must be a flipped board because the king is on a non-canonical square. And then we just, in that position, we just move the king there forcefully, which means that flip just survives, period. So that's good. And it is not illegal, so that is also correct. Then we say the following board is not illegal, that moving the other way around, yes. And then same thing, of course, flip is still set. And then it goes wrong because it says alternate position created from index 0 and alternate position created from index 1. And these are incorrectly flipped. Hey, Louis. How's your coding going, man? Wrote anything interesting? No, not making a chess engine. I want to see what the optimal way to give mate with a rook is on an infinite chessboard. Well, a quarter infinite chessboard. And the code is again way harder than I thought it would be. No, you're not coding right now, but it's the holidays, right? Summer vacation. You can code the whole summer. Did you find other things? Why is flipped set? If the flip was not set, then this would be. Why is flipped set? This is not correct, man. That is a non-canonical position then. You flip the set, and I also print these coordinates differently. So it stores the black king as 0-2. It stores the king as being here, the black king, instead of there. Which is non-canonical, which is not allowed. How did that ever happen? So I think what happens is we create this from the coordinates that you see, or from these coordinates. Wait, no, wait a minute. This also flipped. No, we created from the flipped coordinates. So that would be exactly this. And then flipped must be set, and then it should print this. So the coordinates are wrong. Yeah, I guess girlfriends are more important in life than coding. Although the the best thing, even better, is having a girlfriend or boyfriend that also codes, like I had some point for a few years. That is fun. Then you can be together and code. It's even the best. Coming out a little bit too much. Jason Boo flipped. Oh, this is a tester. Cool. Okay, you're just taking a holiday then. Both. So it's more the beach than here. Yeah, okay. No, yeah, I agree. But you're still on YouTube. Explain that. You're not on the beach now. Although seriously, it's also good to not be together all the time. And then all that time that you're not together, you can just code. I'm not saying you have to, but I would. Because when you're not together, you might as well do what you want to do, which in my case would be coding. So if you go on a holiday together, which is unlikely in your case, Oh, talking about, I have to go do something else as well. I have to go to the shop. I don't have food in the house. And it's past dinner time. It would be a good thing to go buy food now. Instead of trying to do that at 10 p.m. when I really get hungry. And the shops are closed, and then I can't eat. What the hell is this not working? I'm getting tired of it. I'm still having flipped stuff here. But that's just... No, actually. I don't think I can get this right by just guessing, right? I really have to understand what's going on. Hey, Panda. You're just here to play chess. I know it. Oh, wait. No, my program is about chess. Now what? The position doesn't even look a little bit like what it was before. Let's go to the top. Good, this is the first nonsensical one, right? Yeah, this is flipped. Should have been this position, but it is flipped. Does not make any sense whatsoever. Anyway, ID 5 is what is the first one that's wrong. Hmm. What the heck is happening here? So we have this position. No. No. Blah, blah. I'm having this position. And I realized that doing this move is not legal. It's allowed. Therefore, we add the square 0, 0 as the target for the blocking. But before it was moved, the position is flipped. So what you actually have stored is this. And then we get 0, so we put the king there, together with these coordinates for white. Penalty not. So I just so don't understand why I flipped this set here. Let's print even more. The only way to really understand this is by adding a shitload of debug output. So I really start to regret not using my debugging library. I thought, was this a one-day project? As usual, I think that. And let's not do all the trouble of, you know, getting the build system set up. Including everything. Maybe I should. All those standard shouts. But okay. Shall I just stop here and install libcwd, etc.? Takes at least half an hour to do that, and I wanted to go shopping. I guess I just stop and then go shopping and then do it off stream. Adding support for the nice debug output. But I'm still curious. What is wrong? Okay, I'm gonna print it just to stand it out and Okay, output 5. Yeah, that is wrong. It looks like this board, but they're mirrored, which is incorrect. Why is it incorrect? Why is it not printing that it is mirroring it? Confusing. Hi. Okay, I think that basically everything is on the screen now that is going wrong. So we have this position, which has actually the king stored here. This is printed flipped in the main diagonal here. Okay, really the king is there and the white king is here and the rook is there, but we printed flipped. And it prints that. I print now these coordinates non-flipped. Just say flip. So the black king is at 1, 0, which is here, and the white king is at 0, 2, which is there, and the rook is at 2, 1, which is there. Yeah? And black is to play. There's nothing against this. This is 100% correct. Then it starts to move the king around, and it finds that moving the king to 0, 0 is not an illegal move. Because then you get to, well, just this position, where the king is at 0, 0 now, and the white king is still at 0, 2, and the rook is still at 2, 0, and we still must print it flipped. And now white is to play. And that is not an illegal position, because black is not in check. This is therefore added to index 0, but what do we add? The only thing I add is the fact that the king now goes to 0, 0. So leaving king moves, and that then returns a vector with just one square, and the square is 0, 0. So we enter for loop. Now the variable bk of the for loop is 0, 0, the coordinates for the black king. From that we construct a board 0, 0, 0, 2, 2, 1 with white to move. Because we are trying to reconstruct this board, which had indeed those coordinates. So now we have this thing, but flip is not set. And then it calls mirror on that. Why the hell is it doing that? If it would not have done that, then we would have printed, I think, the correct board. Yeah, but the board is actually correct that we constructed. So it looks like the only problem is that the board is being mirrored, while it should not be mirrored. Why am I mirroring it? I'm mirroring it because think we're talking about this one, right? King moves was enter and left, bk is 0, 0. The board is being created here correctly. And then we call mirror on it. Now print flipped is true because the original board, well, the board of the current object has print flipped set. And that is the board that we move to, right? Well, that thing is being printed here. I think this one. That is not flipped. Let's run it in the debugger. Do we enter it? Have it to finish now, then yeah, then nothing. Continue then. Second time we enter it. Yep, second time we enter it, the problem occurs. So flipped is not set. Adjacent board, krijgt het een index 0. Doesn't make any sense. Entering board preceding positions for this. Fix my music again. Just listen to this again, whatever. Okay, entering board preceding positions. For this board. Black king is 0, 0, the white king is at 2, 0, the rook is at 1, 2, as we see, and it's not flipped. Everything is as it looks. So we're going to generate positions with black to play that can result in this position. Yep, these are just the same as these. These are actually the canonical coordinates, but that's also what I print now. Plus it's not flipped. So there is no confusion here. No confusion here, just the coordinates as they are. And since we want to find the positions where black is to move, we're going to move the black king from this position. So we're going to move the king from here to there. And then we find that that position is a position where if black moves the king from here back, we get this position. Moving the king from here to there is a legal position. So it's going to print that that is legal and then return BK position of 0, 1. That square. That's the only one because it's the only legal position. So it says entering king moves board, black for board. Now that's the board. And it finds that this is not illegal, moving the king there. Therefore we return 0, 1. These coordinates. It's printed, 0, 1 is returned. Now we construct a board with 0, 1 and the same coordinates that we see here, that are just the king and the rook, with black to move. But that's not canonical because the black king must be in the upper triangle. So constructing this will change the representation internally. So we're constructing it with a non-canonical coordinates for the black king. And then it says the board was not canonical, so it was mirrored. But flip is set. No. So it's mirrored, being the N and M coordinates are swapped for all of them. But flip means that it's going to be printed and again swapped, so nothing changed basically. Yeah, it can't really understand or test this because print flipped is false. Because that was the original board. So that was this board, which did not need to be flipped because the black king is on the main diagonal. Okay, so with this board, because it is flipped, the canonical coordinates for the white king and well, for the white king is that the king is here, so that's 0, 2, and the rook is then on 2, 1, of course. The rook is here, the way it is stored, and the black king is here. So yeah, if then we call king moves again. King moves doesn't know better than that the board is in the flip position. But whether the king is here or there doesn't matter. The only legal move is, well, apart from taking the rook, but it's going to move to the corner. So it's going to return 0, 0. Doesn't really matter what the position is. So it's not illegal. To move to the corner. There we're going to return 0, 0. Which is then combined with the coordinates of the position that was passed to king moves from adjacent board. These we copied in advance to get a correct position, at most flipped. It depends on stuff, which I don't know, which I don't understand yet apparently. So we should get a position that is like this, or the flipped position. What happened is it just constructed it from 0, 2 and 2, 1. For the white king and the white rook, with the black king at 0, 0. And that particular position does not need to be mirrored, because the black king is at 0, 0. This is where it goes wrong, I suppose. Black king is at 0, 0. White king 0, 2. How do I know that a white king really is at 2, 0? That's this plus that flip, right? Yep, that fixed it. That fixed it. Okay, I'll have to stop. Half an hour till the shop closes. Yeah, the problem was simply that, well, simply the problem was that mirror doesn't really change the position. It mirrors it flips the position, but it prints it still the same. So the actual position doesn't even change, which is wrong by default because the board generates a canonical position. Basically, the board calls mirror if the position is not canonical. Yeah, so the thing is flipped internally but still printed in the same way. If then we call mirror again, then we make it a non-canonical board. So the calling mirror was complete bullshit. What we really want to do is change the position, actually flip it, and then also print it like that, aka mirror it, but not changing the print flipped flag. That is being taken care of by the constructor. And since mirror was only used, yeah, for a purpose where the print flag didn't even matter, I could just change it to not change the print flag, so that now I can use it here. Okay, I'll be back later.